Okay, so we are going to be filling in these proofs from scratch. And so starting off, what we've got is the measure of LIX plus the measure of BIL, so these two blue ones, is equal to the measure of XIZ plus ZIB. And so we're asked to prove that the two blue ones added together is equal to the two red ones added together. And so we can see that that's true because they both form a straight line. So we know that they're both 180 degrees. We just need to go through the process of proving that. So to do so, we need to recognize that these two blue ones form a linear pair. They make this straight line right here. The red ones also form a linear pair. They make that same straight line. So we can say that angle LIX, I'm going to try and match the lettering that they use over here. Angle LIX and angle BIL are supplementary because they form a linear pair. Now, since they are supplementary, their measures add up to be 180 degrees. So we can say the measure of angle LIX plus the measure of angle BIL is equal to 180 degrees. That's because the definition, that's the definition of supplementary. Now the other pair of angles is angle XIZ. And angle ZIB are supplementary. That is because they form a linear pair. So again, those are the red ones. They form a linear pair. Now we can say since they are supplementary, their measures add up to be 180 degrees, just like the other one. I should have just put angle there instead of measure. So the measure of angle XIZ plus the measure of angle ZIB is equal to 180 degrees. And that's definition of supplementary. Now, since they are both equal to 180, we can see that that one is, we can see that this one is equal to 180 and this one is equal to 180. Since they are both equal to 180, they must be equal to each other. That's the transitive property. So the measure of angle LIX plus the measure of angle BIL is equal to the measure of angle, XIZ plus the measure of angle ZIB. And since we took the whole side of those equations and set them equal to each other because they were both equal to 180 degrees, that's transitive. So again, the way we went about this is we said the two blue ones made a straight line. They're a linear pair, so they are supplementary, so they are 180 degrees. The two red ones make a linear pair, so they are supplementary, so they make 180 degrees. Since they're both equal to 180 degrees, they must be equal to each other. Okay. Given the diagram below and the following statements, angle U is a right angle and angle A is a right angle, prove that angle U is congruent to angle A. This would be really easy if we were just to say we could use the right angle congruence theorem, but we can't because we're trying to prove the right angle congruence theorem. And so we're going to say that angle U is a right angle because that's given. And that's given. So the measure of angle U is equal to 90 degrees because the definition of a right angle. We are also given that angle A is a right angle. That was given. The measure of angle A is equal to 90 degrees. That's the definition of right angle. So now, since they are both equal to 90 degrees, U is equal to 90 degrees, A is equal to 90 degrees, they must be equal to each other. Measure of angle U is equal to the measure of angle A. That's transitive. I would accept substitution if you put that there. And now, since their measures are equal, they are congruent because the definition of congruent. So again, we went through and said, oh look, they are both equal to 90 degrees, so they must be equal to each other. If they are equal to each other, they must be congruent. Okay. Let's see. We are given that HAX is congruent to ZUR. So I'm going to mark that on my figure. HAX is congruent to ZUR. We are going to try to prove that XAD and ZUR are supplementary. So what we want to prove is that this one and this one are supplementary. The way that we're going to go about that is to say that these two angles are supplementary and these two angles are supplementary. And these two angles are congruent. So I could replace this angle with this angle, and these two would still be supplementary because I replaced that blue angle with an angle that's the same from over here. I get it if you're feeling confused at this point. It just takes time and practice to get better at these. Okay, so we've got angle HAX is congruent to angle ZUR. That's given. On the left, we can see that HAX and XAD are supplementary. That's because they form a linear pair. Those two angles on the left make a straight line. So they are supplementary because of linear pair. Since they are supplementary, their measures add up to be 180 degrees. And actually, before I do that, let's do that. So the measure of angle HAX plus the measure of angle XAD is equal to 180 degrees. That's the definition of supplementary. Now, since HAX is in both places, we could replace HAX with ZUR, but we can't yet because we haven't converted HAX and ZUR from a congruent statement to an equal measure statement. So what we need to do next is, and we could have done this earlier, is just convert that first statement to say the measure of angle HAX is equal to the measure of angle ZUR. The order or the timing of when you do this doesn't matter. You just have to convert them to measure statements at some point. And so that is definition of congruent. So now we can see that we have measure of HAX, in both places. So I can substitute ZUR in for HAX. So measure of angle ZUR plus the measure of angle XAD equals 180 degrees. We only replace one thing, so that's substitution. Now we can go from a measure statement to since their measures add up to be 180, we are trying to prove that they are supplementary. Since their measures add up to be 180, they are supplementary. So angle ZUR and angle XAD are supplementary. And that's the definition of supplementary. Okay. So again, we proved that those two were supplementary, made a straight line, 180 degrees. We knew that this one was congruent to this one, so we just replaced this one with this one. Okay. Number 4. Prove that measure of angle BAG plus the measure of angle GAM equals 180 degrees. Well, that's pretty simple because look, it makes a straight line. So we can say that they are supplementary, angle BAG and angle GAM. Are supplementary because they form a linear pair. Now, because they are supplementary, their measures add up to be 180 degrees. And that's definition of supplementary. So again, we said these two angles together make a straight line. That's a linear pair. So they are supplementary. Since they are supplementary, their measures add up to be 180 degrees because of the definition of supplementary. Okay, 3 more. Yay. Okay, so we are given that IA is congruent to LH. So I'm going to use 2 marks because that's the longer one. IA is congruent to LH. AE is congruent to HR. We're supposed to prove that IE is congruent to LR. So we're supposed to prove that this whole thing is congruent to this whole thing. So if we think about the way we can do that, we can say, oh look, they both have a 2/ segment, they both have a 1/ segment. If If I add the 2 and the 1 together, I get 3 on both of them. So if I add the parts up to make a whole, those two wholes are equal. And so that's the way we're going to go about this one. We're going to say that first our two given statements, IA is congruent to LH given. AE is congruent to HR, also given. And so again, we can say that we can add up the 2 on the left to get a full segment. We can add up the 2 on the right to get a full segment. So let's go ahead and do that. So the measure of IA plus the measure of AE is equal to the measure of IE. And that's segment addition. For the one on the right, we can do the same thing. The measure of LH plus the measure of HR is equal to the measure of LR. That's also segment addition. So you'll see we have not converted these top ones to measure statements yet. They are still congruence statements. So we need to convert those. So the measure of IA is equal to the measure of LH, and the measure of AE is equal to the measure of HR. And that's definition of congruent. Okay, now we can start moving some pieces around. So we see that we are trying to prove IE is congruent to LR. So we want to keep IE and LR over here. Actually, we want to get IE and LR. So this one's a little bit tricky because what we need to do is make these two have the same thing on the left side so that we can then set them equal to each other. And so what we're going to do, there's multiple ways to do this correctly. I'm going to choose to replace IA here with LH. So the measure of LH plus the measure of AE is equal to the measure of IE. And now what we've got is we have LH in both of these spots. We need to switch out AE for HR. So again, we're going to substitute out AE here with HR there. Okay, and now we can notice that this is a super tricky proof, just to be honest with you. We can notice that now this left side LHHR matches this left side LHHR, and what's on the right there is LR and IE, which is what we were trying to end with. So now, since those are both equal to the same thing, they must be equal to each other. So we can say the measure of IE is equal to the measure of LR, and that's going to be the transitive property. And along the way, I should have been putting my reasons for the others. We replaced only one thing, so that is substitution. That last one was transitive. We need to go from a measure statement to a congruence statement. So IE is congruent to LR. That's definition of congruent. That's a tough one. Okay, we have something similar going on here. We have given that XAB is congruent to GIZ, and BAM is congruent to ZIL. We're supposed to prove that the two angles combined on the left, which make XAM, are congruent to the two angles on the right combined, which make GIL. Okay? The way we're going to do that is we're going to say, well, if we have the blue and the red angle on the left, and we add them up, that will make the big angle. If we have the blue and the red angle on the right, and we add them up, that will make the big angle. And if we did the same thing to both sides and they were equal to start with, they're going to be equal to end with. And so, very similar to the last one we did, which is kind of rough, we are going to have angle XAB is congruent to angle GIZ. That's given. We have angle BAM is congruent to angle ZIL. That's given. I know that I've got congruent statements, and I know I'm going to need measure statements, so I'm just going to do them now. So the measure of angle XAB is equal to the measure of angle GIZ. Definition of congruent. The measure of angle BAM is equal to the measure of angle ZIL. Again, definition of congruent. And so now that we've got that their measures are the same, we can make statements about adding them together to form the big angle on the left and the big angle on the right. So the measure of angle XAB plus the measure of angle GIZ is equal to the measure of angle XAB, GIZ. Anyway, measure of angle XIB plus the measure of angle BAM equals the measure of angle XAM. That's angle addition. And then on the right, the measure of angle BAM. No. Yeah, measure of angle GIZ plus the measure of angle ZIL is equal to the measure of angle GIL. That's also angle addition. Now, similar to the last one, we want to prove that this one is congruent to this one. So what we need to do is do substitution on the left to create a statement that matches, to change one of those statements to make it match the other. And so what we're going to do is we're going to, let's just pick XAB. We're going to replace XAB with GIZ. That will make it match the line below. So the measure of angle, replacing XIB with GIZ, plus the measure of angle BAM is equal to the measure of angle XAM. That's substitution. Now we want to replace the other one. We've got the GIZs matching. We want to change that BAM out for, we want to replace BAM with ZIL. So we're going to go find BAM up here. BAM, ZIL replaces BAM. So the measure of angle GIZ plus the measure of angle ZIL equals the measure of angle XAM. It's also substitution. Now we can see that we have GIZ, ZIL, GIZ, ZIL. The top one is equal to GIL, the bottom one is equal to XAM. So they are equal to the same thing, so they must be equal to each other. The measure of angle XAM is equal to the measure of GIL. That's the transitive property, because if they were equal to the same thing, they must be equal to each other. Then we can go from an equal statement to a congruent statement. Angle XAM is congruent to angle GIL. Definition of congruent. Not the easiest thing. Okay, last one. We're going to say that we are given that WA is perpendicular to MA. And we are asked to prove that MAZ is 90 degrees. So what we're going to do this, we're going to say that the two angles together make 180 degrees. We're going to say that for one of the two angles, perpendicular means that it forms a 90 degree, that it forms a right angle. Then we're going to convert that to 90 degrees, and then we're going to subtract it. So the two angles are supplementary because they form a linear pair, so angle WAM, I think that's enough, WAM, and angle ZAM are supplementary because of a linear pair. And we can pick either one of those two angles to say that they are a right angle because of being perpendicular. We're going to choose WAM for that one. Angle WAM is a right angle. Definition of perpendicular. Now, since it's a right angle, its measure has to be 90 degrees. Definition of right angle. And since WAM and ZAM are supplementary, they must add to be 180 degrees, so measure of angle WAM plus the measure of angle ZAM is equal to 180 degrees. That's the definition of supplementary. We could have put in that right up there underneath the supplementary, which if I were to do this over again, I would. So I would make it look like this. Okay. Now we can see that WAM plus ZAM is 180 and WAM is 90. So if we were to subtract WAM from up here, we could subtract 90 from over here. So because of subtraction, we would get the measure of angle ZAM is equal to 90 degrees because of subtraction. And that's actually ZAM and MAZ are the same angle, it's just said backwards. And that's it.